So, why'd you guys break up?
I don't know, I guess we just weren't on the same wavelength.
Oh, well, of course you guys weren't on the same wavelength.
People used to think that light was just a bunch of light particles traveling in a straight line. However, it turned out that light also behaved like a wave. Now, it's not literally that light traveled in the shape of a wave. Instead, a wave could represent where the particle could be, with the peaks representing the places where the particle was more likely to be. Each particle has its own unique wave.
Are you telling me that I'll never find my perfect boyfriend?
No, of course not. It just means you have to find someone who matches your wavelength.
When two light particles meet, they combine to create a new wave that looks like a completely different pattern of light. This is known as interference.
This discovery about light behaving like a wave rocked the physics world. But my buddy, DeBroglie, took this one step further. He said that it wasn't just light. All moving matter had its own wave. And he even came up with an equation to calculate the wavelength of an object,
which is just the distance between two similar points on a wave. In this equation, wavelength is calculated by Planck's constant divided by momentum, where Planck's constant is just this really tiny number, and momentum can be defined as the power of a moving object, and is calculated by mass times velocity. So, for someone weighing 75 kilograms, which is a lot more than a subatomic particle, and walking at 1.3 meters per second, his wavelength would be ridiculously tiny. And this is why we can't see the wave nature of everyday objects.
However, mass is only half the equation. What if you tampered with velocity?
By cooling down bosons, you can eventually slow them down enough that they collapse into a wave. This is known as a Bose-Einstein condensate, and it can be used to simulate the quantum world.